Okay, so this is the density lesson. Okay, so we're going to look at density and see what's the story with density, what's going on. Right, so you're happy enough with mass. Okay, so mass is the amount of stuff in something. So how much mass something has is how much stuff is in it, and we measure it in grams or in kilograms. Okay, that's a kilogram. Okay, a kilogram. Right. So grams or kilograms. Okay, a liter of milk is effectively approximately a kilogram. So you have that idea. There are 1,000 grams in a kilogram. So you get the idea of this mass. Okay, and I have a mass of about 85 kilograms, and you have a much smaller mass. Okay, but we have the idea of mass. And mass is fine. Okay, works well as long as you're talking about one particular material. That's great. Then the question asks, the old-fashioned question is, which is heavier, air or board or iron? Okay, so this is your air board. You know your air board? Okay, and this is iron. Okay, it's made out of iron. So which is heavier? Okay, it's not a trick question, but it is a question that you can't answer because we don't know. The problem is, well, let's say you're probably thinking that iron is heavier, but let's have a look. Okay, I'm going to pause this here now, and I'm going to move to a different place, and hopefully you'll see it following through. Hopefully this will work. Okay, we're back. Now we're going to wait. So we were saying which is heavier, iron or air board. Okay, so let's weigh them. Okay, just zero that there, so it's zero. So look, so I've got a piece of iron here. Okay, 50 grams. 50 grams. Okay, right. And I've got a piece of air board. Here we go. 82.2 grams. So, air board is heavier than iron. Now, of course, you'll suddenly say to me, but they're different amounts. And that's exactly the point, okay? You can't compare like with like, okay? You can't compare two things unless you compare like with like. You can't say iron is heavier than air board unless you say, okay, I have a certain amount of iron and a certain amount of air board. And that's what density is. So density, right, is the mass of something divided by its volume. And this is the formula that you have to be able to deal with. Density is mass divided by volume. And what that actually means is, it actually means, we're going to talk in grams and centimeters cubed, okay? So you understand, it is the mass of 1 centimeter cubed of a material. Now what's 1 centimeters cubed? Well, you know what a cube is. That's a cube. Okay, that's a cube. Okay. Right, sorry, that's a cube. Okay, now that's actually 2 centimeters cubed. That cubed. That's 2 by 2 by 2. So we go to the simplest one, which will be the density of the mass of 1 centimeter cubed is what we call density. But then you can compare like with like. Okay, so for example here, okay, I have iron, okay, and I have cork, for example, okay, and now I can compare these like with like because they're exactly the same amounts of each. So if I get the mass of one and the mass of the other, I'm comparing like with like. So that's what density is. It's the mass of 1 centimeters cubed. So think of a little cube, 1 centimeter by 1 centimeter, 1 centimeter. So if you're told the density of iron, you say density of iron is whatever, 420 grams per centimeters cubed. It would mean that there are 420 grams in 1 centimeters cubed. And air board would be much, much, much less. Okay, so that's step 1. Okay, that's step 1. We'll look at the calculations later. Okay, that's step 1. Okay, that's what density is. Now, what about density of water? Okay, water is interesting. Okay, and the density of water is defined. Okay, is density of water 1 gram, and the way we say is per, that's divided by our per, divided by centimeters cubed. So this means 1 gram for every centimeters cubed. So water, every centimeters cubed of water is 1, right? 1 gram per centimeters cubed, and that's defined. Okay, that's what it is. Now, if something has a density less than 1, it'll float in water, and if something has a density more than 1, it will sink in water. Okay, so that's interesting as well. Now, iron has a density more than 1, it'll sink. Okay, cork will have a density less than 1, and so on. Okay, so we're just going to have a quick look at a few here now, okay, and see how it works. Okay, so I have a bowl of water. Okay, so I have my bowl of water here. Okay, let's see how this goes. Okay, we'll be able to see it. Okay, and if I take my iron, okay, so you'd expect the iron to sink, and it sank. Okay, you can just about see it there. Okay, if I take my cork, so the iron is denser than the water. Okay, if I take my cork floats. Okay, cork floats. Okay, so cork is less dense than water, and so on. Okay, take your apple. Okay, take an apple. Floats. Avocado, that's we're posh in this house, sinks. Okay. So that tells you whether something is more or less dense than water. Okay, very interesting. You may wonder about a boat, an iron boat floating, but remember, in the iron boat there's loads of air, so overall the iron in the air of the boat is less dense than water, and therefore it floats. If the iron was solid, if the boat was solid iron, it wouldn't be a boat, it'd sink. Okay, it'd be no good to us. All right, so that's the idea, okay, of density. So you need to have the idea of what density is, and then we need to do the calculation. So let's go back on it. It is the mass of 1 centimeter cubed of material. So density is mass divided by volume. So now it doesn't really work for me because I'm loads of different bits. Okay, so it only applies to things that are all the one thing. Okay, but if I was all made of the one thing, and you took 1 centimeter cubed of me and found my mass, that would be my density. Okay, it'd be mass of 1 centimeter cubed. Okay, so remember that density is the mass of 1 centimeter cubed. And think of 1 centimeter cubed. Think of your little cube. Now this is, as I said, is twice in length, twice and twice, all twice too big. 1 centimeter cubed. Okay, so a cube of 1 centimeter by 1 centimeter, 1 centimeter. Put it on the balance, and that would tell you the mass, the density. Okay, and remember, why do we have to have density? Because if we don't, we're not comparing with like back to our experiment with the aeroboard. The aeroboard's mass of what I used was more than the mass of iron, because there was a huge more volume of aeroboard. If we worked the densities of both, the density of iron would be much greater than the density of the aeroboard. Okay, so that's the introduction to density. We're going to do some calculations on a separate clip, and we'll give you a few to try, and then we'll talk later in the day.